Hello, these are the solutions of the mechanics review sheet. So, in number 1, there is a ball thrown from the top of a cliff. Initial magnitude of the velocity is given by v. And we have the graph. We're asking for the graph of v versus time for the vertical component. So, if this is v, the vertical component is going to be v sine theta, and this is going to be v cosine theta. Since a vector is always the longest side, the hypotenuse in a right triangle, the components will always be smaller in magnitude than the vector itself. And since we are looking for the vertical component, the initial speed vertical should be less than v. So it cannot be a, it cannot be b. It can only be c or d, and we choose d because the height it's thrown from is there, but it falls more than that. It continues falling, so the downward movement, displacement is going to take a longer time than the time it moves up, so that's why we choose D. Number 2 says a body is moving on a straight line, and we want to show motion with non-zero acceleration and non-zero initial velocity. Now, there is an acceleration, which means the displacement time graph cannot be a straight line, so we eliminate A and B. Then we're left with C and D. They're both curves, but we now know that there is non-zero initial velocity. Remember, the slope of displacement time graph gives velocity, and initially this graph has zero gradient. So initially this curve has a zero velocity, which is why we pick D, because initially the gradient of this curve is non-zero. Number 3, we are relating displacement and time. So looking at that formula that we now relate the two with zero initial speed because initially at rest, S is given as D, and we can write an equation of 1/2 a t squared. So we're given in time t, it falls distance d. So we need to write an expression for the initial situation. And then the situation changes. What is the time taken for the object to travel 16d? So here is where we need to look at the relationship between d and time. You can see from this function that d is proportional to the square of time. So 1/2 is a constant, acceleration is the same because, well, the question also tells you that it's the same acceleration. So these don't matter. We are looking for that proportionality. This means d is proportional to, that's a proportional to sign, to the square of time. So for example, if you square the time, this is going to be 2t squared, so d will be 4 times bigger. That's what it means to be proportional to the square of time. The question gives us we are going to move 16d. Well, to cause d to be 16 times bigger, t would have to be 4 times bigger. See? So that 4t squared would be proportional to 16 times d. So our answer is C. Number 4 is a momentum question, but I will answer it anyway for the sake of the completion of this worksheet. We have a spaceship moving at constant speed in outer space. An internal explosion causes it to break into 2 pieces that move in opposite directions. And what happens to the total momentum and the total kinetic energy? Well, for starters, total momentum has to be unchanged. That's the law of conservation of momentum. Initial momentum of a system is conserved unless there are external forces acting. So since we know it's in outer space, there's no air friction, so total momentum is going to be unchanged. the total kinetic energy will be changed, and we can only choose B here because the different individual masses will be moving in there with their own speeds, and the total energy will change in that case. So that's a B. Number 5 is the same question as number 3, so we know the answer is C. We'll just pass. Okay, that brings us to number 6. We are looking for equilibrium. We know that it is moving at constant velocity. That means the mass is in equilibrium, which means the net force is 0. So we need to look for every force that acts up must equal to every force that acts down, and every force to the right must cancel every force to the left. That is in D. A lot of people, very common mistake is to say C because weight looks equal to the reaction force, which is what we are tempted to choose. But remember, this force also has a vertical component, so this cannot be imbalanced. This one will, because weight of that magnitude down, acting force is acting up, pulling up, making the weight impact less on the base, which reduces the reaction force, so answer is D. Number 7, we're supposed to choose 3 vector quantities. Now, I will underline the terms that are not vectors, which means that they don't have directions. So in this case, pressure is a non-vector. It doesn't have a north-south or right-left direction. Electric current is not a vector, which means our answer will be A, because momentum is a vector, electric field strength is a vector, displacement is a vector. Right now, maybe you haven't learned all of these concepts, but it's good to practice vector quantities. So number 8, which of these is necessary for an object to be in translational equilibrium? This is the definition that I mentioned in the previous question. It doesn't mean the object is stationary. Object can be moving with constant velocity. So this is not necessarily the case. It is possible, but not necessarily. The object must move with constant speed. The trick here is it says speed. In circular motion, speed might be constant, but the direction would be changing, so that is not in equilibrium. We are looking for constant velocity. It's not among the options, but C says the resultant acting on the object must be 0, so this is what we are looking for, so the resultant force, net force, is 0. Also, D is wrong because equilibrium doesn't mean no forces. It means that obviously there are forces, but they all add up to 0 total. Number 9, a stone is thrown vertically upwards from the surface of Earth. Which of the following quantities will not become 0 while the stone is in air? Acceleration will never be 0. Speed will be 0. Velocity will be 0 at the very top, where also momentum will be 0, but acceleration is constant. Acceleration of gravity, that will not be 0. Question number 10. A puck moves on a straight line. It moves at a steady speed of 20 meters per second and experiences no frictional force. How far does the puck travel in 2.5 seconds? Well, you simply multiply 20 and 2.5 and you get 50 because, well, for the sake of solving it completely, we use this equation where it's moving at constant speed, so acceleration is 0, so you end up multiplying velocity by the time, and you get 50. Number 11, we have a diagram on an inclined plane with the angles shown. Which of the following gives the resultant force? So we're looking for the resultant force. It's not in equilibrium, but we're looking for the unbalanced. So if all forces are balanced, the resultant force is 0. If there is an unbalanced force, that is the resultant. So let's look at the components of weight. This perpendicular to the base will be weight times cosine of the angle, and parallel to the plane is weight times the sine of the angle. You should see that that force is balanced by that, and there's nothing balancing this one. There's no friction. So our answer is going to be that one right there. Number 12, we have balls X and Y that are at the same height. Y is just dropped and X is thrown horizontally. So ignoring air resistance, which statement is true? If you look at the choices, we are comparing the time that they take to fall. They will hit the ground at the same time because their vertical motion is exactly the same. Initially, their vertical velocity is 0 for both, and they have the same height. So the time in the vertical to fall will be identical. It's going to be equal to 1/2 gt squared. That will be the height they fall from, so they will fall the same height. The only difference is Y will fall down straight. X will also fall down straight, but also move horizontally at the same time. Question number 13 gives a skier that accelerates. This means we know that F net is not equal to 0. There is a tow rope pulling the skier, and there would be friction from the base. And we are supposed to choose the correct statement about the force on the tow rope. So number 1 states that it is greater than the magnitude of the total resistive force acting on the skier. Now, we don't know that this must be true. We know it accelerates, but we don't know which direction it is accelerating. We don't know if it is speeding up or slowing down. So we cannot choose number 1 for sure. Number 2, equal to the magnitude of the force exerted on the rope by the skier. Definitely, because there's an action-reaction pair here. This one basically says if the rope is pulling the skier with a force of tension T, the skier is also pulling the rope back with the same tension. So this is an action-reaction pair. That would be correct. Is it equal to the magnitude of the force causing the boat to accelerate? Nope, this is irrelevant, so we choose C. Number 14 is the same as the vector quantity one before. We already discussed this. 15 is another momentum question. So we want to know a mass of 0.4 kilograms in a time of 0.2 seconds bouncing from a wall, hitting the wall towards the right with 5 meters per second, and then bouncing back with a speed of 3 meters per second. So if we use F delta T equals M delta V, basically impulse is equal to the change in momentum. We're solving for force, so I'm really looking for the mass times the change in velocity divided by the change in time. Now we know mass, which is 0.4. We know the time, it is given as 0.2. The change in velocity, this is a vector quantity. We have to consider the directions. If 5 is towards the right and 3 towards the left, we will assign a positive for the 5 and a negative for the 3. And to find the difference, we're gonna look at the change in velocity, final minus initial, including the directions, which is going to be -3 minus a 5. So this is final velocity, and that is initial velocity. So I'm basically going to add the magnitudes. The change from a 5 to a -3 is an 8. So calculating this, that would be 8 times 4 divided by 2 would be a 16. And the last multiple choice question, we have a ball that is projected horizontally with a speed v, the height is h. What do we need to know to find the horizontal distance traveled? Now, let's think about what we would need to find the horizontal displacement. That is s in the x component, which would be ux times t plus 0, 1/2 at squared, the 0, because the acceleration along the x is 0. We know air resistance is negligible. The question tells us that. Well, what do we need to know to calculate this? I need to know ux, which is v, okay? And I'm going to need the time. How do I find the time? I would use the height to find the time. So I need the height and the velocity to calculate this, which is in option C. We don't need the mass. There's no air resistance, and mass is not in any of our calculations. We're not looking for force. So answer C.